Alright guys, so we're going to go through question 4 now. Ready? So the first part's really easy. Tim's basically told you this already. There's the breeder's equation. If you write that down, you get all the 10 marks. The second part asks you what do each of these terms represent. So we have our trait distribution Z. This is how our trait is distributed. And we're interested in looking at how the mean of that trait distribution changes with time. So what you'd have is you'd have some trait Z and some frequency. And what we're interested in is how the mean value here shifts. Does it shift down? Does the trait get smaller, or does the trait get bigger? And this is known as Z bar, the mean. So we have our mean trait, and delta, just the Greek symbol, means a change in. So we're interested in looking at how the mean of the trait distribution changes through time. So what is it that actually changes? So we have to look at the selection differential, S. And what does this tell us? This tells us the difference between the mean of the parental population and the mean of the trait that has been selected to reproduce. So it's the average trait of the selected parents minus the average trait of the parental population. It's basically the individuals that are chosen to breed. And then how does this get transmitted across? Well, we have to look at how much of that phenotypic trait that's been selected for is actually due to genetics. So your traits are based on the environment and the genetics, but only the genetic part of the phenotypic trait can be inherited, and that's what our H squared represents, our heritability. So you have the change in the parental trait, the selected parents, how much of that will be transmitted to the offspring, and that gives you the change in the mean trait distribution. Now if we go on to the third part, we're asked just to put some values into this equation and solve it to find S. So from here, if we divide through by H squared, we have the change in the mean trait divided by the heritability, and that just equals S. So we have these values. Delta Z bar is 0.3, and we're dividing it by H squared, 0.1, which just equals 3. And what does this biologically mean? This is saying that the change, or the selected parents, are 3 kilograms heavier than the mean in the